Today's video will introduce us to something known as homeostasis, specifically human homeostasis. What exactly is homeostasis? Well, homeostasis is a process that allows us to maintain our internal environment despite dealing with an external environment that is constantly changing. You see, the conditions with our body can fluctuate a whole lot for many different reasons. A hot day outside might cause an increase in our body temperature. The consumption of that delicious hamburger will increase our blood glucose levels. Or the stress from studying from that big test might raise your blood pressure just a little bit. Fortunately, our bodies have mechanisms to counteract these changes and bring us back to those normal conditions where our bodies function best. I'm talking about homeostasis. All homeostatic mechanisms will have three components involved in the regulation. The receptor will sense any fluctuation within the environment and proceed to send a signal to the control center. The control center will then determine what sort of response is required to the change, and it will send the signal to the effector. The effector will then receive the signal and adjust accordingly. When the effector adjusts in a way that attempts to stabilize a variable, that is, bring it back within a normal range, it's called a negative feedback loop. While positive feedback loops also exist within the human body, negative feedback loops are far more common and will therefore be our focus today. So let's look at one of our earlier examples of homeostasis, that is, body temperature. Temperature homeostasis, also known as thermoregulation, is happening constantly within our bodies. Let's see how our body adjusts on those hot sunny days. A section of our brain, known as the hypothalamus, helps us detect fluctuations in temperature. It receives signal from receptors on the skin, as well as internal structures, and decides what should be done. This is just like a thermostat in your house, turning on and off the heating or air conditioning. The hypothalamus links the nervous system, where the receptors are, to the endocrine system, a collection of hormone-secreting glands. If the hypothalamus detects an increase in temperature, it would signal certain glands in the body to secrete sweat, which would in turn cause heat loss due to evaporation. On top of this, the hairs on your body will lay flat, releasing warm pockets of still air caught between them, and the muscle walls of the arterioles will relax, causing an increased flow of blood to the capillaries in the skin, allowing more heat to escape. In cold environments, we would see the opposite happen. The hypothalamus would signal the glands to decrease sweat production, the muscles will cause body hairs to stand on end, and blood flow will be directed away from the outer capillaries and towards the warmer core of the body. We only looked at one example of how stable levels of a variable, in our case temperature, is maintained in our body. But as you can see, homeostasis occurs with many other variables, ensuring that our bodies function at their optimal condition. I hope you learned a lot from this video and will continue to learn all about homeostasis. Thanks for watching.
Created using Powtoon.